Recordings rolling. It is Wednesday, February 25th. Ooh, before I go to this, let's look at top scientists for fluid dynamics. So, top scientists. All right, awesome job if you made the cut. So I'm still waiting on a few more quizzes before I hand these back. But yeah, awesome job if you're a top scientist. All right, so what are we doing here? Last couple of days, you guys been going through this SAT. Let me make sure. Guys, the packet I'm printing right now. Make sure it has an 8. Does it have an 8 right here? Has an 8. It does not have a 9. It has an 8. Okay, because I have different ones for different classes. Right. And so we're going to go over the answer. It's going to take us a few days. Right. And you guys are all taking notes. Everybody has paper, notes. Right. So just a reminder, there's 2 modules of math. Collectively, it's 70 minutes to do 54 questions. That you guys are doing 27. That you guys have your grids out. Yeah.
Do you have the answer paper? Can I have one?
Oh, you need one of these grids?
Yeah.
Yeah. All right. Yeah.
I didn't know.
Okay. You agreed?
No, I agree. The packet.
Oh, packet. Okay, we get to a packet. Right, you want to know this? Okay, packet. All right, does anybody else need anything? So everybody's got this. Okay. Sure. Okay, 5th period. Did you guys do that infrastructure test? Probably. Okay. So they were trying to get the whole school to do the infrastructure test at the same time. Everybody opens Blue Book. Guys, when you take the SAT, it should be through Blue Book, and that's why they just want to make sure the system can handle it. All right, so let's jump into it. One thing here, it's good to be aware of that they do give you some reference formulas. So a lot of geometry, areas of shapes. They got the Pythagorean theorem. We got the volumes of these 3D objects. They gave you some pointers here. I think I went over with these the other day. So they don't like mixed fractions. Don't ever write a mixed fraction. But they can do decimals or improper fractions, okay? If there are 2 answers, sometimes there's more than one correct answer. Just pick one, right? Circle one, okay? So that might show up. All right, number 1. Oh, and you guys probably saw too that the first few questions are like easier and they get harder and harder. And there's some actually pretty tough questions when it gets towards the end, but of course we'll do all of them. So number 1. A bus is traveling at constant speed along a straight portion of a road. The equation d equals 30t. That's like distance equals speed times time. Gives the distance in feet from a road marker that the bus will be traveling t seconds after passing the marker. How many feet will from the marker will the bus be traveling 2 seconds after passing the marker? Okay. So the big picture, if I can cut back up and make this even more general, is distance equals speed times time. Right. Well, a little bit physicsy here, right? But also my algebra classes with the other packet we were doing. This is one of these equations that you kind of have to know. Right? I think you guys could, right? Like if you do 60 miles an hour for 3 hours, how far have you gone? 60 times 3, so it's like 180 miles, right? Something like that. And this one's like feet in seconds, something like this. Right? So you have to know this going in, and then this shows up a few times. And for you guys, this is the first question. Now their version of it is distance equals 30t. Okay. Distance is in feet and time is in seconds. So, I got my own question. Guys, here's my own question, which SAT could totally ask you what I'm about to ask you. How fast is this bus traveling?
30 feet per second.
30 feet per second. Yeah, 30 feet per second. Okay. Now, they want you to put a 2 here for 2 seconds and say the distance is equal to what?
60.
60. Right, and that would be feet. Although they're just looking for numbers. Right. Oh, also, guys, if it's not multiple choice, these are not all multiple choice. Don't write units. Okay, should you write units? Not for the SAT. So you just write SAT. Now this one looks like it's option C. Here, I got the key next to me, so I'm going to be checking as we're going along. Okay, yeah. Okay, so CC. Okay, number 2. For a particular machine that produces beads, 29 out of 100 beads have a defect. A bead produced by the machine will be selected at random. What is the probability of selecting a bead with a defect? I'm not even going to write anything down for this. Because what's the answer?
C.
C. Yes, 2 is C. Are you guys okay with 2 is C? Mm-hmm. Right. So 29 out of 100 beads have a defect. That's C. Number 3. Oh, guys, does this look kind of like an exponential curve? I think it is. I think it's like shifted up 6. It's basically an exponential curve, isn't it? I'm going to go that deep. What's the y-intercept? So basically, where does it cross the y-axis? And it looks like it's right there. Is that at 8? So 0, comma 8 could be the coordinate. Would that be D?
Yes.
Are you guys okay with 3 is D? Right, so 3 is D, 0, comma 8. That's that y intercept right there. Okay. Number 4. Which expression is equivalent to? Okay, let's paper time. Number 4. You guys taking notes? Notes, good for the brain. 2x squared plus x minus 9. Now they did throw that in parentheses, so why not? Right, plus, and then we have a group of x squared plus 6x plus 1. Okay, guys, since we're just adding 2 groups of numbers, could I just drop the parentheses and it makes no difference at all?
Yep.
Yeah, this particular one, that's true. Okay. So let's get the x squared together. How many x squareds are there?
3x.
3. So 3 of the x squareds. How many x's? 7 x's and
8.
minus 8. There you go. That should be the answer. Let's see. Number 4. Do they have something like that? Yeah, it looks like D. Make sure it's 4D. 4, yeah, 4 is D. 4 is D. You guys got 4 is D? Okay, number 5. An analyst collected data on the price of a carton of grape tomatoes at 30 locations selected at random in Utah. The mean price of a carton of grape tomatoes in Utah was estimated to be $4.43, with an associated margin of error of 8 cents. So sometimes a little pricier, sometimes a little cheaper, kind of averages out to 4.23. Okay. Which of the following is a plausible statement about the mean price of a carton of grape tomatoes this in Utah? Right. Well, if you have here, spell this out. Okay. They're saying that the price should be $4.53 plus or minus 8 cents, something like that. Okay. So here, maybe sort of like a number line here. Let's put 4.23 right in the middle. Okay. Guys, if you subtract 8 cents, what do you get? 4.15. If you add 8 cents to the average, you get what? 4.31. Right. So really, I think the prices of these tomatoes should be somewhere between 4.15 and 4.31. Right. I think that's where they're going with this. Let's see. That's what option A says. The price is between 4.15 and 4.31. That's what we said. Is 5A? Yeah, 5 is A. Right, 5 is A. All right, so you guys got 5 is A. 5 is A. Remember, it's 2.6 plus x is 2.8. What is x? Yeah, there you go. Right, so you guys got it. I'm just going to write it down just for completion here. 2.6 plus x is 2.8. Subtract 2.6. Both sides. X equals 0.2. There you go. Oh, and that one is not multiple choice. Okay, my answer key is telling me they're actually accepting 2 answers on the answer key. They would accept that. And what's a different way to also write this? You can reduce that to 1/5. So if you write 1/5 and then bubble in the bubbles for 1/5, so 1/5, they would also accept that. So you can do 0.2 or 1/5. They'll accept either answer. If you did not reduce it to over 10, I don't know. I think you probably have to simplify it to 1/5 if you do fractions. Right, number 7. Oh, this is also no multiple choice. Out of 300 seeds that were planted, 80% sprouted. How many sprouted? Oh, so number 7. We have 300 seeds. Okay. Now, if they say 80%, I should do times what?
0.
Yeah, 0.8. Like that. Okay. What's 8 times 3?
24.
24? Great. And if you flip the decimal, the actual answer is what? 240. There you go. Should be 240. Okay. 240 out of 300 should be 80%. Let me check the key here. Yep, 240. Got it right, 240. 240. Are you guys good? 37? Okay.
Sure.
No, just the words are right. Yeah. Okay. Yeah. Yeah, so you guys should be taking notes, but the notes are just for you guys to help you out. Okay. It helps to take notes in class because helps your brain work, helps you learn better anyway. Right? And then of course you can look back on it later and actually. And so f of x equals 4x plus b. So that's this number 8 for the linear function, b is some constant, and f of 7 is 28. What's the value of b? Right. Okay, so they gave us a different coordinate. Let's try that. So f of 7 is 28. So if I plug in 28 for f of x, that's true when x is 7. Okay, we can use that to solve for b. What does b equal to?
0.
0. B equals 0. That looks like option A, doesn't it? Option A. Is 8 A? Yep, 8 is A. You guys got 8 is A? Okay. I want to do one more thing with this. I want to give you guys a visual, do a graph here. So on an XY set of axes, okay, what would this actually look like? Could you draw that graph? What's the slope right here?
4.
Yeah, 4/1. There's the slope. And then the y-intercept is 0. We just got that. Goes through the origin. Right? Just like that? Yeah, so there's a graph for the scenario. Number 9. Right triangles, element and PQR are similar. Guys, if two triangles are similar, that means they have the same what as each other. Starts with a name.
Angles.
Angles, same angles, right? So maybe you have a small triangle and you blow it up into a big triangle, but the angles stay the same. They could be similar. Where L and M correspond to P and Q, respectively. Yeah, see how they did like first letter, second letter, third letter. Okay, so typically you name triangles like angle L is equal to angle P and so on. L, yeah. Angle M is 53 degrees. What's the measure of Q? So I would definitely draw this one out, so I'm going to do that here. So number 9. Now they did say something about 53 degrees, okay, which is actually a special angle that you guys might recognize from physics. So let me get this going. And so that was angle M, or something like that. Okay, you got a smaller triangle here. Okay, let's do M. And how about L and N? And then if I match these up, yeah, that'd be like Q could be here. And this would be T. And this could be point R. All right. So here, I put the two triangles kind of on top of each other so they share the 90 degree. You don't have to do that. You could draw them two separate here. But these two triangles would be similar, right? Triangles, wouldn't they? Yeah. Because this angle matches this angle. And they told you M is 53 degrees. Okay. There are a few different ways you could correctly draw this. I just picked one a little bit. Okay. So what is this angle right here?
53.
Yeah, 53 degrees. 50 degrees. Okay. Maybe a way you could gotten that faster is if you just look at the strings of letters. Okay. You see how M is the middle letter in the set and Q is the middle letter in the set. Okay. And all the letters are respective to that word respectively, like they're in order. Right? So the angles have to be the same. So it's got to be B. The answer's got to be B. Let me check my key over here. Is 9B. Yep, 9 is B. 9 is B. 53 degrees. You guys get it? 53 degrees? Okay. Okay. Yeah. Here I got some extension questions. What is this angle up here?
9B.
37 degrees? Yeah, 37. Okay. Because these two acute angles each have to add up to 90 and 90 and then this 90 makes 180. How about this? If these angles are very, very, very close to a scenario for special right triangles. What special right triangle has angles extremely close to those?
3, 4, 5.
3, 4, 5 triangles. So yeah, the proportions of legs are like 3 to 4 to 5. Yeah, or very close to that. Okay. Yeah, it shows up in physics a lot. Right. Number 10. What is the equation of a line that passes through the point 0, 5 and is parallel to y equals 7x plus 4? Right. Now, you might be able to get that just in your head, but I'm still going to draw this out so you can see it anyway, because I like to see this. So,
The y-intercept is 5.
yeah, I'm going to start with that other line. They said 7x plus 4.
Yeah.
So, 3, 4. Now, this might not be exactly to scale, but could you guys imagine this could have a slope of up 7/1? Could you guys imagine that was the case? Okay. And this, the line they refer to goes to the point 0.05, which is like right here. That's 0.5. They want it to be parallel. So that means it would have to have the same slope, which is also 7/1, right? Okay. Okay, so this line right here. Okay, because I know this one's y equals 7x plus 4. Okay. So this one is what? Y equals what?
5.
Yeah, 7x plus 5. Is that true? I give you that. That should be what we're looking for. Let's see, number 10. That looks like B. Is that right? Is that B? Yeah, it is B. It is B. Okay, we're getting all these. Are you guys good with 10 is B? Is good? All right. Number 11. Like a scatter plot, but there's a really strong trend here. There's strong correlation. The following equations is the best linear model for this. Linear model. Guys, if I hold my ruler here, we can make a y equals mx plus b out of that. Guys, what is approximately the y-intercept up here?
1.
Yeah, it's pretty close to 10. Okay, so I'm gonna let's do a new paper here. This is number 11. I'm gonna follow the form y equals mx plus b. And we just said b is very close to 10. I'll just call it 10. Okay, and then what is approximately the slope of this? It's down what over what?
1. It's negative. But
Yeah, it's negative.
Yeah.
Right, so that helps. Okay. Guess how it goes down 10 and across a little more than 5?
Yeah.
All right. If I round that a little bit to make my own equation, okay, down 10 over 5 is very, very close to down what over what reduces to.
down 10. Down.
What is down 10 over 5?
-2.
-2. Okay. So this might not be exactly the answer, but this should be pretty dang close, right? Okay. Let's see whatever's closest to that. And really the slope is maybe not exactly -2, maybe it's like -1.9 or something. Okay. All right, let's say. Yeah, what do you think? Which letter is that?
B.
B. Aha. We got a slope of about -2 and a y-intercept of about 10. Right, that's the only one. Okay. All these other ones are not really it. Looks like B. Yes, the answer is B. Number 11 is B. Okay. Number 12. A model predicts that the population of Bergen was 15,000 people. 15,000 people in 2005. The model also predicts that each year for the next 5 years, the population P increased by 4% of the previous year's population. Which model? Which represents the scenario? Right. Okay, hold on. Where X is the number of years after 2005. Okay. Okay. So this is this is something I generally do with my algebra students. I know a few of you guys are in my algebra class. Okay. It's the same formula, guys. Exponential growth. It's the same formula that you use for banking.
Compound.
Yeah, and compound interest. Yeah. Same thing. Okay. Guys, how does that formula go? Because this is one of these formulas that you have to know going into the SAT. Or at least you have to know basically what it looks like. So how well do you guys remember this?
D10.
Yeah, so population as a function of time equals
A.
you could say A or initial principle or some version of that.
Principal times 1 plus percentile.
Yeah, 1 plus the growth rate.
Yeah.
And then there's one more detail.
T to the.
Yeah, there you go, to the power T. Exactly. Okay. In banking, this is called simple interest. And then again, this could be population growth. Right? Are you guys good with that? Like, for example, if the growth rate was 5%, I could put 0.05 here. And in parentheses, this would be 1.05. And then every year that passes, time to be 1, 2, 3, 4. Right? You're multiplying by 1.05 again and again and again. You're taking whatever initial population. Now it's growing. Now it's getting bigger. Okay. Let's go back to these numbers. So they said 4%. So in place of R, if R is 4%, do I want to put 4 for R?
No.
No, I want to put what?
0.04.
0.04. Yeah. Now don't forget that's being added to 1. So really this is 1.04. Okay. And then the initial population was 15,000. That goes right here. Now we got population as a function of time. Okay. That's probably what they're looking for, isn't it? Here, I'm going to rewrite that one more way. So 15,000 times 1.04 to the T. I think that's the best answer. Let's see if that's a choice. Right, so number 12, do I see anything looks like that? Yeah, I think it's D, isn't it? Is that D?
Yep.
Yeah, D. All right, 12 is D. All right, you guys go. 12 is D. 12 is D. Oh yeah. All right, 13. Ooh, system of equations. Here, I'll write down the system over here so it's bigger. We got 2A plus 8B is 198. And then 2A plus 4B is 98. The solution to the system of equations is AB. What's the value of B? Okay. So, guys, there's different ways to solve systems of equations. Are you allowed to subtract one equation from another?
Yes.
Yeah. In fact, that's the way I would do it because that immediately does what?
Gets rid of the A.
Yeah, it gets rid of the A's. 2A minus 2A goes away. And then you're left with 4B is 100. So what is B equal to? 25. And that's what they asked. They asked what is B. And that's not multiple choice. I'm looking at the answer key. Yep, it says 25. That's right. Bing. So you had to write 25. Okay, right, 25. Okay, let's do an extension here. Let's go back and get A. I wonder what A was.
-1.
Is it? You might be right. Let's see. Okay, so I got to claim it's -1. So let's leave that true. So in the place of B here, I'm going to put 25. Now this is equal to 98. Okay. Okay, so this is 100. I'll subtract 100. Yeah, 2A equals -2. Yep, sounds right. Yeah, so A is -1. Just a little side thought. They could have asked that. All right, number 14. Expression 90y to the 5 minus 54y to the 4 is equivalent to, well, this other looking expression, where r is a constant. Oh, there's a little r in the mix here. What's the value of r? Because when they say equal, is equivalent to, can you just say equals and solve it? Yeah, that's exactly what I'm going to be doing. So let's try. So 90y to the 5 minus 54y to the 4 is equivalent to. And then y to the 4, 15y minus 9. Okay. Like that. Now, yeah, there might be a lot of different ways to go about this, but here, the way I might do it is, what can I factor out of the left side?
Y.
Y to the 4. I'm going to take a y to the 4 out. Y to the 4. Okay. While I'm at it, 90 and 54 are both even numbers, so I can at least take a 2 out. Okay? And I think I can take more than that out. Okay? Because these are also both multiples of 9. Yeah, I could take a 9 out too. I could take a 9 out, and I could take a 2 out. So guys, what's 9 times 2? 18? I can at least take 18 out. Let me try that. Okay. So what is 90 over 18 is 5. So I have a 5 and a y here. Because 18 times 5 is 90. And y to the 4 times y is y to the 5th. So that'll complete the first term. Okay. Then minus, what is 54 over 18 is 3. So you got 3. That's all. Okay. Because this times this would be this. Okay. Okay. That's equal to, okay, it's over here. So got got a y to the 4. Oh, actually, I can take something out over here. Guess what can I take out of here? A 3. Yeah. So times 3 times, I got 5y minus 3. That's okay like that, right? Ah! What could you do now? You cancel a ton of stuff. 18 equals 3r. So what's r equal to?
6.
6. Yeah. Is that multiple choice? Oh, nope, that's not multiple choice. But the answer is 6. Bing. Answer is 6. Okay. And maybe you solved it a different way because there could be different ways to go about it. So you guys got all that? Good. All right. Number 15. Ooh, okay, got a graph. Looks like it's some kind of cubic. Graph is shown. Yep, let's define f of x as x to the 3 plus bx squared plus cx plus d. A, B, C, and D are constant. For how many values of x does f of x equal 0? Ah, another way to say that. But what's another way to phrase that?
Times the cost on the y-axis.
On the
X-axis.
yeah. How many times does it cross the x-axis? Right. That's where f of x or y would be equal to 0. And how many times does it cross the x-axis? 3. So it should be C. Let me make sure it's 15 C. Yeah, 15 is C. You guys go with 15 is C? Okay, let's find out. All right, 16. The area in square centimeters of a rectangular cutting board can be represented by W plus 9, where W is the width. Here, I'm going to draw this one out. So let's go. Here's a cutting board. We got W plus 9. Like that. Which expression represents the length in centimeters of the cutting board? Oh, you know what? I think you're looking at the answer right there. If the width is W, what's the length?
Plus 9.
W plus 9. So is that D? I think it's D. 16. Yeah, 16 is D.
How do we know this?
Because the area is W times W plus 9. Now, if you draw it out, it could look like this, right? Like width times length. So that area would be W plus 9, which is that's the first thing I told you. Okay. So if the width is W, then the length must be the other dimension, which is W plus 9. Yeah. All right. Number 17. P equals K over 4J plus 9. Distinct positive numbers P, K, and J. Okay. Positive numbers P, K, and J. So all we know about P, K, and J so far is that they are positive. They are greater than 0. Which equation correctly expresses 4J plus 9 in terms of P and K? Well, why not? Let's see if we can chase that down.
Yeah.
So P equals K over 4J plus 9. Okay. And we need to find 4J plus 9. All right, so let's try. What I might try to do is like try to. Oh, actually, you know what? That's just this right here, isn't it? Yeah. Okay. Guys, can I just cross multiply that and divide down the P? Right. So 4J plus 9 equals, and then it should just be that, isn't it? Is that the same thing? Okay. P over 1, same thing. Okay. I think that's the answer. And is that a multiple choice? Is that D? No. K over P. Sorry, other way around. A. Yeah, A. 17 is A. 17 is A. 17 is A. Yeah, you guys got 17 is A. 18. Circle A has radius 3n. Circle B has radius 129n. For n is some positive constant. The area of B is how many times the area of A. All right, let's draw this out. This is a fun one. I was looking for a question like this. All right, so, well, all right. Okay, this is not the scale at all, but just get the idea. Okay. You have maybe like 3 in here, like 129 in here. Okay, just get the idea, right? Okay. Now, if I ask you the ratio of the radii, could radius 2 over radius 1 be 129 over 3? Okay. How about this? Guys, what is diameter 2 over diameter 1? Is that the same thing? Yeah, it's the same thing. What is circumference 2 over circumference 1? What is that? Okay. Same thing. Okay. No, the ratios are all the same. Yeah. Yeah. Times 2 to get the diameter, but then if you take the ratio, the 2 cancels out.
Yeah.
Times 2 pi to get the circumference, but then if you take the ratio, it cancels out. So all 3 of these ratios are the same ratio. It's 129 over 3. Okay. But that's not what they asked. They asked something about the area. Now, if I change the circles to squares, the answer really leaps out. Okay. Guys, what if you have, say like this is 3 units, and this is 129 units. Okay. So the ratio of the sides could still be also this ratio. Okay. Oh, but area, that's different. Guys, to get area, what do you have to do to that side? You have to square it. You have to square it, right? Okay. And do you think that this ratio, if you square the ratio, that also becomes the ratio of the areas? Okay. Now, to make a circle, if you want the exact area, you have to like bring in a pi and the whole thing. But the ratio, the important thing is that area 2 over area 1 is 129 over 3 collectively squared. You have to square it. Or for the multiple choice, they may have written it this way. I forget, I haven't. It might be like that, some version of that. Okay. Okay. Actually, let's what I got this ready for this right here. Guys, let's talk about scaling a little bit. There's a question. I forget if it's your guys' question or the algebra packet question, but there was one question where they have two boxes and they compare like the areas and they ask for like what's the relative volumes, right? And you really have to know how scaling works, which is relevant to this question anyway. Okay. So guys, let's look at this box. If we just focus on this box for a moment, um, do you guys see a small box down here with some side length, whatever, right? And then the large crate has 3 times the width, right? 3 times the width, 3 times the length, 3 times the height. Okay? And there are these different properties that scale at different factors. Right? So if I ask anything linear, it's just a factor of 3. The width, the depth, the height, right? The perimeter for that matter. If you walk around the small box into the big box, it's all the same thing. It's all a factor of 3. Okay? But what about this? What if you buy a bunch of paint? Okay, and I bought some paint to paint that surface right there. Paint that surface. Say, hey, I want to paint the surface of a large crate. How many times the paint do you need? 9 times. Do you see it's like 1, 2, 3, 4, 5, 6, 7, 8, 9 squares right there? Is that right? Or you can just take the linear factor 3 and square it because we're talking about area. 3 squared is 9. Right? What if both of these boxes cast shadows? What if they got separated by some distance and they're both casting shadows? How big is the big shadow compared to the small shadow? Guys, does the shadow cover area? Cover some area on the ground, right?
Yeah.
So how many times is the shadow?
9.
9 times. It's 9 times the shadow. Right? What about this? Let's switch. New question. What if I fill this little box with water? Bloop. I say, I want to fill the big crate with water. Bloop, 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 bloop. How many times the water do you need to fill the big crate compared to the little box? 27. Right? You guys see you could pack 27 little boxes. 3 by 3 is 9. And then they got the first story, the second story, and the third story. Right? Or you can just say 3 times 3 times 3. It's the same answer. 3 times the volume. Right? All right. So there's. Are you guys good with scaling? Okay. Because that's the question you guys got here. So now we're going back to SAT land. Back to SAT. Okay. The ratio of the radii is 129 to 3. Therefore, the ratio of the area, you just square it. Okay. So let's see here. Okay. So we got some hard numbers here. Let's pop that in the calculator. So we get what is 129 squared divided by 9. I'm looking at 1849. 1849 times the area. Okay. Is that an answer choice? Yes, it is. It's option D. So 18 should be D. Is 18 D? Yes, 18 is D. 18 is D. Right, you guys good with 18 is D? All right, number 19. The measure of an angle R is 2 pi over 3 radians. The measure of angle T is 5 pi over 12 radians greater than the measure of R. What is measure of T? Oh, in degrees. In degrees. Okay. So there's a couple ways you can work around this. Here, I'm going to start with the unit circle to remind you guys how that works. And if you totally don't know any of this, you can still get the answer, but let's one thing at a time here. Okay. So let's start with the unit circle. Unit circle. Okay. Now, traditionally, unit circle, the x-axis down here represents like 0 degrees. Okay, and we're going to sweep around relative to that. Okay. So guys, if I sweep up this angle right here, how many degrees is that?
1/2.
Degrees. How many degrees? 90 degrees, right? Guys, isn't this right here?
Yeah.
90 degrees. Okay, so here's 0 degrees. Here's 90 degrees. How many degrees over here?
180.
Yeah, 180. Okay, how about down here?
170.
Yeah, 270. And then back around?
360.
Yeah, 360 degrees. And now you're back where you started. Okay, that's degrees. Okay. Now we're going to switch to we've definitely done radians in physics, right?
Yeah.
Okay. Okay, so now how many 0 degrees could be 0 radians? That's okay, right? Let's go all the way around the circle first. How many radians are all the way around the circle?
2 pi.
2 pi. 2 pi radians. Okay. Because remember what that tells you is if you multiply by the radius, it will tell you the physical distance around. And you guys know those equations, circumference equals 2 pi r. It's the same thing. Same thing. Okay. Well, okay, so if it's 2 pi radians all the way around, how many radians halfway around?
Pi.
Just regular pi. How about this 90 degrees?
Pi over 2.
Pi over 2. It's radians, radians. Okay. How about this guy?
3 pi over 2.
Yeah, 3 pi over 2 radians. Okay. Right. So from this perspective, we got 2 pi over 3 radians. So 2/3 of a pi. That's like right here, isn't it? 2 pi over 3 radians. Okay, so that's this angle. Okay. Is that 120 degrees, I think?
Yeah.
120 degrees, I feel like. And they got a different angle. 5 pi over 12. Okay, that's a weird angle. What is 5 over 12? That's a little less than half. E. Well, that might be like hereish. I'll call this 5 pi over 12. Right. But you know what? At some point, it's probably good to just do a conversion anyway. Okay. So how do you convert from radians into degrees? Take however many radians, multiply by whatever what.
60.
That'd work, sure. 360 degrees over 2 pi radians. Right. And oftentimes you also see 180 divided by pi. So you might see that too. Yeah, you can do that. Equals number of degrees.
And then like if you want to convert degrees radians, it's just like
Sorry.
Yeah, well, since they asked for degrees, let's just go ahead and do the conversion first. Right.
okay, yeah.
Yeah. Because I was gonna add these two together, but now it's like looking like messy fraction. I mean, we could, but
That's what I
just
did.
all right. Yeah, pretty good. All right, so let's take a 2 pi over 3 radians. All right, and multiply by, well, I'll do 180 over pi. That'll give you 120 degrees. So we got that angle. And then let's do 5 pi over 12 radians. Multiplied by 180 over pi. What is 5 twelfths of 180? It's 75 degrees. Yeah.
Did you also say 90 degrees? I mean, yeah, 90 degrees over pi halves.
Yeah, you can do that too. Yeah, that'll work. Okay. And then, wait, they want you to add these together? So that what is yeah. It says T is this many radians greater than this. Yeah, okay, so we do have to add this together, okay? Does that make sense why we're adding together?
Yeah.
Because one angle is this many more than that angle. So that gives you 195, I think, degrees?
Yeah.
I think that should be the answer. 195. All right, so that's an answer choice.
Yes, it's C.
C? Let me make sure 19 is C. Yep, 19 is C. 19 is C. That's good. 19 is C. All right, number 20. Y equals x squared minus 14x plus 22. Guys, if you graph that, what shape would that make? Parabola. That's a parabola right there. Yeah. Okay. Oh, the given equation relates x and y. Oh. For what value of x does y reach the bedroom? Guys, that would represent the what of the parabola. Starts with a vertex. Yeah, vertex. Okay, guys. This one right here. This is a question that comes up all over the place on SAT math. Is for some reason it's just really good to know the vertex of a parabola going to the SAT. Okay. Okay. Hey guys, if you have the form y equals ax squared, guys, what I'm writing right now, you have to know this for the SAT. It'll pick you up points. I guarantee it. Ax squared plus bx plus c. Right. So some form of a parabola. All right, parabola. Right. And here, draw a little parabola here. Maybe some looks kind of like this, x, y. Okay. If you want this x value of the vertex, x vertex, and I bet some of you guys know this, equals what? Yeah, you should definitely know this for the SAT.
And it's what's that?
It's always negative b over 2a. Okay? Guys, know that. Definitely put that in your notes. Know that. That'll pick you up points on the SAT. Okay? Right. And same question right now. Okay. So we have the equation y equals x squared minus 14x plus 22. It says what value of x does y. Okay, so yeah, this will solve it exactly. So we'll go x vertex equals, so negative b, isn't that like negative 14?
Yeah, so probably 14.
And then 2 times, there's an applied 1 here. So it'd be like that, wouldn't it? So what's that? 7. So the answer is 7. Okay. And then if you wanted to graph, there's my little graph picture right there. So it could be x is 7. Okay. Oh, this was not multiple choice, but I'm looking at the key, and the answer is 7. Yeah. So, okay, you guys go with parabolas, find the vertex. Okay. Let me do one more thing with it, just in case you get this question. Guys, what if you wanted to find the y value? What would you do?
Factor.
Take the 7 and plug it in. Guys, if I take the 7 and plug it in for the x's, can that give me the y value?
Yes.
Okay, so if you saw something like that, you did.
7.
Alright, 21. A small business owner budgets $2,200 to purchase candles. The owner must purchase a minimum 200 candles to maintain the discounted pricing. The owner pays $4.90 per candle to purchase small candles and $11.60 per candle to purchase large candles. What's the maximum number of large candles to stay within the budget, but also maintain discounted pricing? Right? So he has a budget constraint, so he can't buy 1,000,000 candles. He can only buy so many candles, but he has to buy at least 200 of these candles to get the discount. Right, so there's this conundrum, right? He has to buy at least so many, but not more than so many. Right. So let's see. Yeah, let me pass. Nice.
I didn't want it. All right, so back here, I know I definitely saw this one ahead of time. Yeah, so these are getting trickier here. Let's see if we can do this. Let's do. See if we can come up with something. So $2,200. He's doing right. Could be equal to. Let's do $4.90 per small candle. Guys, I'll call small candles X, and then $11.60 per big candle, and then big candles could be Y. Okay. Okay. So X equals small candle. Y equals big candle. Okay. All right. All right. All right. But really, guys, this shouldn't be equal. This should be an inequality. Which way should I draw the inequality? The center.
Yeah, let's try it. Because guys, I can't spend $2,300, but I could spend $2,100.
Yeah.
So I think I have to draw it this way. Isn't that true? Or maybe something like that. Is that true? Right. So there's one inequality. So we'll put that to the side. But there's this other constraint of 200 candles. Right? You have to buy at least 200 candles. So guys, when I say X plus Y, and I compare that to 200, should X plus Y, can it be less than, or does it have to be more than?
More than.
Yeah, more than, possibly equal to. So that. But so here's our set right here. Now, if you graph both of these, there's probably like some graph space where it is, right? But we're looking for the maximum number of large candles. Right. So max number of large candles. Right. See, could Y be greater than or equal to 200 minus X? I think I can get from this equation, right? Like that. Okay. And let's try this. Let's plug this into this and see what happens there. Right. So you get 2,200 greater than or equal to 4.90x plus 11.60. And in place of y, let's try 200 minus x. We'll see where this lands us. Okay. So distribute 11.6 by 200. 4.9x plus 2320. That's 11.6 at 2,200. Okay. Get the x's together. 11.6 minus 4, 9. Like this. Okay. So I'm getting 6.7 x greater than or equal to 2320 minus 2,200. 120 divided by 7. Okay. I'm getting x is greater than or equal to 17.9 candles. Okay. Now, guys, this is small candles, right?
So around that.
Okay. So, yeah, let's try 18 and see what happens. Guys, we'll do a guess and check, and we'll go back and just make sure it works. So, guys, if x's was 18 candles,
yeah,
then what would y have to be? Have to be at least 182, right?
Yeah.
Because 182. Right. Right. That is the answer. Now I'm looking at it. Now, if I was actually taking the SAT and I had enough time, I would go back and check my work. But that is the answer.
Okay, so we had to write this out. The answer is 182. Okay. Okay. Yeah.
Do we turn this in now or?
Hold on to it, and then we're gonna keep going next few days.